Hey everyone, and welcome back to this class, the Numpy stack in Python. In this lecture, we are going to compare lists and arrays. So at first glance, you might think, what's the point of using a Numpy array? Doesn't it look exactly like a list? So let's go into IPython, and let's do some examples. So we'll start by importing Numpy. And now let's make a list. Let's make an equivalent array. So these both give me the same thing with 3 elements, 1, 2, and 3. One thing we do frequently is loop through lists. So let's try that. So for E and L, we're just going to print E. Okay, so that works fine. Now let's try the same thing with the array. So that works as well. So these work exactly the same. So you might still wonder, what's the point? Let's say we want to add something to our list. With a list, we can use append. So we append 4, and now L contains the element 4. But what happens if we try that with a Numpy array? So there is no method append on a Numpy array. Now there is another way for us to add an element to a list, and that's to join 2 lists together. So let's try that with the list first. Okay, so now L also contains 5. Let's try this in Numpy now. Let's try to add 4, 5 since it doesn't have a 4 yet. Okay, so that also doesn't work. It seems we can't add anything to a Numpy array. So maybe now you're thinking, Numpy really sucks. It can't do the things that even a list can do. But let's try something else. Let's try vector addition. To make it really simple, we'll just add a vector to itself. With a Python list, we know that if we use the plus sign, it's just going to give us a new list with all the elements concatenated, but we don't want that. So what we'll need to do is add each element individually. So I'm going to create an empty list. I'm going to loop through each element in L. And I'm going to append E plus E. And once that's done, L2 is equal to L plus L. So how might we do this in Numpy? Let's try A plus A. Okay, so that gives us exactly what we want. So that's your first lesson. The plus sign with lists does concatenation, but the plus sign with Numpy arrays does vector addition. If you had a matrix, which is a 2-dimensional array, it would do matrix addition. To generalize that concept, what this does is element-wise addition. So what's another way to get 2 times a vector without having to add it to itself? Well, you could just multiply it by 2. That's a scalar multiplied by a vector. So let's try that in Numpy first. So 2 times A. That also gives us the expected result. Now let's try this with our list. 2 times L. Interesting. So what it did was repeat what was in the list 2 times. So just because this behaves differently doesn't mean it's useless. In fact, I use this number multiplied by list notation quite often. If you did want to multiply every element of the list, you'd have to do a for loop and go through each element individually, just like what we did to get L plus L. As a last exercise, let's try to do an element-wise squaring of every value in the vector. Let's try it with the list first, even though we know it's probably not going to work. Okay, so that doesn't work. You can't pow a list. We can still do this with the list though, we just need to use a for loop. So L2 equals empty array for E and L, L2.append E times E. So now L2 contains the expected elements. Let's try this with Numpy now. As expected, it works, but it works much more simply. So one thing you should keep in mind about Numpy is that most functions act element-wise. So you've seen a raised to the power 2. What about square root? That's just np.sqrt. So that takes the element-wise square root of the vector. How about the log? So that's np.log of a. So that does the element-wise log. How about the exponential? That's just np.exp a. So that's the element-wise exponential. For all of these, if you wanted to do them with a list, you need to use a for loop and do each element individually. So to summarize, what we learned in this lecture was that if we want to represent a vector, a NumPy array is a little more convenient, since it does what we expect it to do when we do things like add, multiply, and square. Lists are good too, and there are many cases where you want an actual list and not a NumPy array. Usually you can treat a list like an array. With NumPy you can treat an array like a vector, a mathematical object. To do operations on lists, we need to use a for loop. As you'll see later, for loops in Python are very slow, so you should avoid them when you can, when you're doing mathematical operations.